Hi, this is a debriefing for chemistry CP. The homework assignment was molar mass, grams, moles, and molecules. Directions for each show your work by indicating all units and show your conversion table. Number 1, part A, convert the following to molecules. 88.5 grams of ammonium perchlorate, or whatever that's called. I don't even care what it's called anymore. What I care about is what is the gram formula mass for that. So first, we need to establish what is the gram formula mass for that substance. And I'm just going to go quickly on my calculator and say, well, for nitrogen, there's one nitrogen, and that is 14.007. I have 4 hydrogens, so 4 times 1.008. I have 1 chlorine, so that's 35.45. And I have 4 oxygens, so that's 15.999. Add them all together, and it says 117.485. So I'm going to go 88.5 grams times 1 mole for every 117.5 grams to 4 sig figs times Avogadro's number per mole. So if I go 88.5 divided by this answer, 0.753 times Avogadro's number times 6.022 times 10 to the 23rd power is 4.54 times 10 to the 23rd power. So 4.54 times 10 to the 23rd power molecules. So 2 things. I did not bother re-entering the 117.5. I just used it out of my calculator memory, which means it actually used 117.485. And secondly, I didn't bother multiplying times 10 to the 23rd power because this is times 10 to the 23rd power as well. So just a little shortcut to get this debriefing done quickly. H3PO4 is hydrogen phosphate. I have 0.171 moles of it. It doesn't matter what the gram formula mass is because they're asking for the number of molecules. So 0.171 moles times Avogadro's number per mole is all that we're after here. So if I go 0.171 times 6.022, enter, it displays 1.03. So 1.03 times 10 to the 23rd power molecules. Letter C, 321 grams of iron 3 permanganate. Well, this is when we have to first write the formula correctly. So iron with a 3+ charge is teaming up with permanganate, and permanganate has a 1- charge. It's MnO4 with a 1- charge. So I'm going to need 3 permanganates for every iron. So open parentheses, MnO4, close parentheses, subscript 3. That is iron 3 permanganate. Now I need to determine the gram formula mass for iron permanganate. And on my periodic table, I'm going to sum together the masses of 1 iron, 55.845, plus 3 times the permanganate is 54.938. Add to that 4 oxygens, so 4 times 15.999, close parentheses, and voila, it says the gram formula mass is 412.647 grams per mole. So if I go 321 grams times 412.6, 1 mole for every 412.6 grams. then multiply that by Avogadro's number per mole. In other words, if I go 3, 2, 1, divide by the current answer, I have 0.778 moles times 6.022 times 10 to the 23rd is 4.68 times 10 to the 23rd. 4.68 times 10 to the 23rd power molecules. Letter D, 1.45 moles of carbon tetrachloride. I don't care what the gram formula mass is for carbon tetrachloride because I'm just using Avogadro's number. 1.45 moles times Avogadro's number per mole is 1.45 times 6.022 is 8.73 times 10 to the 23rd power molecules. Number 2, convert the following to moles. I have 8.12 times 10 to the 22nd molecules. Well, so 8.12 times 10 to the 22nd power molecules times 1 mole per Avogadro's number. So if I go 8.12 times 10 to the 22nd power divided by 6.022 times 10 to the 23rd power, I have 0.135 moles of cobalt 2 phosphate. My guess. Part B. I have 106 grams of silver nitrate. I need to know how many, well, I need to know the gram formula mass for silver nitrate. So I'm going to sum together the mass of one silver atom, 107.87, plus one nitrogen atom, 14.007, plus three oxygen atoms, 3 times 15.999. Enter. I have 169.874 grams per mole. So if I go 106 grams times 1 mole for every 169.9 grams, in other words, if I go 106 divided by the answer on my calculator, I get 0.624 moles. 0.624 moles. Letter C, I have 123 grams of calcium hydroxide. Well, calcium hydroxide, I have to use parentheses because a hydroxide polyatomic anion, I need 2 of them, not 2 hydrogens, I need 2 hydroxides. So parentheses. Now that's neutral, and I need to know the gram formula mass of calcium hydroxide. So I sum together the mass of 1 calcium for 0.078 plus 2, open parentheses, oxygen is 15.999, hydrogen is 1.008, close parentheses, enter, and the gram formula mass is 74.09 grams per mole. So if I go 123 grams times 1 mole for every 74.09 grams. In other words, if I go 123 divided by the number currently displayed on my calculator, result is 1.66 moles. Letter D, I have 8.21 times 10 to the 24 molecules of sulfur dioxide. It doesn't matter what the substance is. I have this quantity. So if I go 8.21 times 10 to the 24th power of anything, in this case molecules, and I say, well, that is 1 mole for every Avogadro's number. This will tell me how many moles I have. So 8.21 times 10 to the 24th divided by 6.022 times 10 to the 23rd is 13.6 moles. Of sulfur dioxide. Oh, so much for the front side. But wait, there's a back side. Number 3, part A. Convert the following to grams. Oh, gosh. Okay, convert the following to grams. 7.09 times 10 to the 21st power of molecules of tin 4 fluoride. I need to know the gram formula mass of tin 4 fluoride. So on my calculator, one tin atom is 118.71. I have 4 fluoride atoms, so 4 times the mass of one fluorine atom is 18.998. Enter. So the gram formula mass is 194.7 grams per mole. 194.7 grams per mole is the gram formula mass. So if I start with 7.09 times 10 to the 21st power molecules, and then I convert that to moles by saying it's 1 mole for every Avogadro's number of molecules. And then, now that I have the moles, I say it's 194.7 grams for every mole. So if I go 7.09 times 10 to the 21st power divided by 6.022 times 10 to the 23rd power times the answer still on my calculator display, I get a result of 2.29 grams. Part B. I have 3.21 moles of copper 2 bromide, and they want to know how many grams, so I need to know the gram formula mass. Well, for copper 2 bromide, bromine is always 1 minus, copper 2 means it's 2 plus, so I'm going to need 2 bromines for every copper. And if I go 3.21 moles times the number of grams per mole, I will have my answer. So for copper 2 bromide, that's going to be 1 copper mass, 63.933, plus 2 bromines, which is each one is 79.904. Enter. I get 223.7. So 223.7 grams per mole times 3.21, and I get 718 grams. Letter C. I have 0.676 moles of magnesium sulfate, and I want to convert that to grams. So first I have to correctly write magnesium sulfate. Magnesium is Mg, always with a 2 plus charge. Sulfate is SO4 with a 2 minus charge. And there it is, sulfate, SO4 with a 2. You can't see it. Sulfate, SO4 with a 2 minus charge. So no need for parentheses. I just need one of each, MgSO4. And I'm going to go 0.676 moles times the number of grams per mole. That means, firing up my periodic table and calculator, I'm going to sum together the mass of one magnesium atom. Magnesium has a mass of 24.305 plus 1 sulfur atom, so 32.06, plus 4 oxygen atoms, each one is 15.999 grams, and I get 120.4 grams per mole. So if I just multiply that times 0.676 moles, I get 81.4 grams. Letter D, I have 1.87 times 10 to the 24th power molecules of lead 2 chloride. I need to take 1.87 times 10 to the 24th power molecules and convert that to moles, knowing that it's 1 mole for every Avogadro's number of them. Then I need to multiply it by the gram formula mass, the number of grams per mole. Using my calculator, 1 atom of lead has a mass of 207.2, and I'm adding to that the mass of 2 chlorines. So 2 times 35.45, enter. I have 278.1 grams, 278.1 grams per mole. So if I go 1.87 times 10 to the 24th power divided by 6.022 times 10 to the 23rd power times the number of grams per mole that I had on my calculator display, I get 864 grams. Number 4. A chemistry student weighs out 205 grams of potassium chlorate and applies heat. The solid decomposes to oxygen gas and solid potassium chloride. How many grams of oxygen gas and potassium chloride are made? So we first have to write the skeletal equation correctly, beginning with potassium chlorate. Going to our handy dandy table, we know that potassium is always going to be a 1 plus charge, and chlorate is a polyatomic anion with a 1 minus charge, written as ClO3. So this is KClO3, and it's apparently in a solid state. Chemistry student weighs out 205 grams of it and applies heat. So I believe I have to show that as a delta symbol, meaning applies heat. Somewhere, the solid decomposes to oxygen gas and solid potassium chloride. All right, so potassium chloride would be KCl. Every chlorine is always a -1. Every potassium is a +1. One of each makes them all happy. But before I can do anything else, I now have to balance the skeletal equation. So I build up my rap sheet and I say, interesting. I only have 2 oxygens on the right, but I started with 3 on the left. So how about if I put a coefficient of 2 here and 3 there and see if I can make it work out? That would mean I would have to put a 2 over here and now try everything. 2 potassiums on the left, 2 potassiums on the right, 2 chlorines on the left, 2 chlorines on the right, 6 oxygens on the left, 6 oxygens on the right. This is now a balanced chemical reaction. I now need to calculate the gram formula mass for the potassium chlorate, for that matter, also for the oxygen, and for the potassium chloride. So for each one of these, I need the gram formula mass. Starting with the potassium chlorate, that would be the mass of, for 1 mole of it, it would be the mass of 1 potassium. And as I look at this balanced chemical reaction, the coefficients are as low as they can be. I'm going to need 2 moles of this substance for every 3 moles of this substance and every 2 moles of that substance produced. So instead of calculating the gram formula mass, I'm going to calculate the gram formula mass and then double it in this situation and say, well, that's what I need for my ratioing. or that's what I'm going to choose to use for my ratioing. So I'm going to double everything and say 1 potassium is 39.098. Add to that 1 chlorine, which is 35.45, and add to that 3 oxygens, which is still 15.999, close parentheses. So I would need 245 grams for 2 moles of this. Okay, 2 moles is 245.1 grams. 2 moles. Now, I only have 205 grams. So if I go 205 divided by the number on my display right now, that will tell me I have 0.836 of 2 moles. Okay, so I have 0.836 of 2 moles. Or I have 83.6% of 2 moles of this. I'm probably doing this in a way that confuses you. Sad, but I'm going to keep going. My point is, if I only have 84% of what I need here, I'm only going to make 84% of what I want there and 84% of what I want there. So in every case, I have 0.836 of, in this case, 3 moles of O2, and I have 0.836 of 2 moles of potassium chloride, because I'm starting with 0.836 of 2 moles. If I had 100% of 2 moles, I would make 100% of 3 moles over here, and I would make 100% of 2 moles over there. If I only had 1 mole here, 50%, I would only make 1.5 moles, 50% of the oxygen, and 1 mole, 50% of the potassium chloride. So now I'm going to calculate how many grams I have if I have 84% of 3 moles of oxygen gas. One way of doing this. So 0.836, which I could have left in my calculator display, times 3 moles of diatomic oxygen. I claim I'm producing 80.3 grams. 80.3 grams of O2 gas. And you could do subtraction since there's no other outlet for the mass. So if I start with 205 and I remove 80, then what I have left is like 125 or so. But let's do it based on my logic that says I have 0.836 of 2 moles of the mass of potassium, which is 39.098, plus the mass of 1 chlorine, which is 35.45. There's the gram formula mass in parentheses, multiply, enter, and I get 124.6 grams of solid potassium chloride. As a check, this plus this should equal that by conservation of mass. So what is 124.6 plus 80.3? And the answer is 204.9. So within round off error, I'm saying, yes, I am fine. This concludes the debrief on this homework assignment.